Hello YouTube, this is UMills03. So we've made it to lesson 7 in the Java programming curriculum. We've already talked about a lot of content. Of course, in lesson 0, we downloaded the BlueJ IDE. Ever since then, we've talked about printing statements, we've talked about comments, we've talked about arithmetic expressions, order of operations, modular arithmetic, division, multiple variable declarations, initialization, a little bit of variable conversions, and then we talked a lot about string objects and string methods and looked at a bunch of them between lessons 5 and 6. So feel free to look at the links to those in the descriptions if you need a little bit of a refresher. I wanted to take one more video to talk about ints, doubles, and strings because these are really important data types in Java. We've already said that Java prefers doubles over ints. So let me tell you what I mean by that, and we're going to do a little bit of a review here. So you remember the refresher from lesson 6 is that these are the string methods that you should be familiar with. So remember, this starts with, ends with, index of, last index of, replace all, replace first, substring, toString, is empty, equals ignore case, length, two uppercase, two lowercase, and concat. So how many methods are there? We probably have like 1, 2, 3, 4, 5, 6, 7, 8, 9, about 15 methods, and a couple of them have more than one way to use it. So there's about 15 to 17 methods that you should be familiar with from the string class. But for now, remember, if we say something like int a equals 3.0, there's an issue here because you cannot pass a floating number to an int even if it ends in a 0.0. But what you could do is you could say, double a equals, int 2. You could even just say 2 or int 2. No matter how many times you try to force that 2 to, as much of an integer as you can make it, the fact that a is declared as type double means that a is still going to come out as 2.0. So if you do something like, for example, a times a, right, 2.0 times 2.0, Java prefers the double, so it's going to remain as a floating point. The floating point representation is going to be sustained, and that's why we get the 4.0 instead of the 4. And we said, well, if we want to solve that, if we want to go from a double to an int, we need to do that explicitly. So for example, if you say something like, system.out.println, if you do just int 5.0 plus 1, you'll get 6.0, right? Or this would be 6, right? So if you do, this, then this will be 6.0, right? Because if only the 5.0 gets converted to a 5, then, a double plus an int is a double, okay? But if you say system.out.println of int 5.0 plus 1.0, then this would just be 6. So hopefully you guys are clear with that, and then we can all, we can go back and forth with this stuff. So you could have said double A equals, 5. But here, this is equivalent to A equals 5.0, equivalent to saying double A equals 5.0. Or, there's so many different ways to say the same thing. Double A equals, you could have said double of 5. You could have said double of 5.0. You could have said int of 5. You could have said int of 5.0. But all these times, it's going to be converted to 5.0. And so hopefully that's clear to you exactly how that's working. Because if it's declared as type double, that's how it's going to come out. The only way that it wouldn't is if you converted the output of it. So if you said I want the int form of a, then we would get the 5. So with this output, we're expecting 6.0, 6, and 5. Okay, so essentially that's what would happen here: 6.0, 6, and 5. Okay, so we're pretty clear with how to convert from ints to doubles and which of the two Java prefers, and you guys should be pretty comfortable with that. And go back to probably lesson 3, but especially lesson 4. Lessons like 3 and 4 if you need a refresher on that. What about when strings come into the mix? So let's say we do something like this. So let's say we have string A equals 5, and then we're going to say string B equals A plus 2. System.out.println of B. So the question is, what happens here? Because we have a string, we have the letter 5, right? And then we're going to combine it with an integer. The question is, can we concatenate a string with an integer? The answer is yes. So Java prefers doubles over ints. Moreover, it prefers strings over doubles, and ints, right? So what would happen is the 2 is going to actually be converted to the letter 2. Okay, so 5 combined with 2, it's not going to be 7. It's not going to do 5 plus 2. It's going to do 5 combined with 2 to get 52. And that's what would happen here. So that's what the essence of this video is to show you that an int is going to be implicitly cast to a string object when you concatenate them together, and that's what would happen. And if you do b.length here, this is going to be recognized as a string. What if you did something like system.out.println of a plus 3 dot length? This should just be 2, okay, because this 3 is converted to the letter 3, and then you get 5, 3, and the length of the string with the numbers 5, 3 in it is 2. So that's why you see a 2 here. So hopefully that's clear to you. And so that's what would happen. And the same thing happens with doubles. So if you said something like, what if you said double y equals 18? Okay, so really this is going to become 18.0. And then what if you do string a equals, what if you do 3.4? And you say system.out.println of a plus y? What's going to happen? So the 3.4 string literal is going to be combined with whatever y is, and y should be 18.0, but the 18.0 is going to become a string. So it's going to be 3.4 combined with 18.0. So really we should be looking at 3.418.0. Okay, and we can double check that, but that's kind of the output that we would be expecting by combining those two string objects. Okay. So that's what would happen here. The string does not get converted to a double. The double gets converted to a string, just automatically. That's what would happen. And so that's really what you should be familiar with here, and what you should try to understand. And so that is essentially what would be going on here. What if you really do want to convert a string to an integer, or a string to a double? Because we see it with this example what Java prefers, right? We said not only that Java prefers doubles over ints, but also that Java prefers strings over doubles. So in turn, it also provides strings over ints. So what happens if we want to get an int out of a string? Let's say we have two numbers that are represented by strings, and we want to add them together. So we want the result of 4 plus 5. What you need to do is convert those two strings to integers. The way you do that is as follows. What you're going to do is you're going to say int c equals Integer.parseInt of a. So what the Integer.parseInt method does, Integer.parseInt of s, accepts a numeric string s. So s is a string, but it holds digits. So maybe it's like 382 or something like that. So it's not technically a number, but it kind of looks like a number. And then accepts a numeric string, and then makes the actual mathematical integer out of it. So it accepts 382, and actually out comes 382, the value, the number, the quantity. Okay, so here this is actually going to be the number 4. Okay, so now if you say, for example, what if you say c mod Integer.parseInt of b? What would this code do? Well, c is literally the number 4, so we're going to do 4 mod literally the number 5. So if you divide 4 by 5, what remainder do you get? And the answer is 4. So that's what would happen here, 4. And of course, and then just kind of to demonstrate this point further, if you combine this with the string, so you do 4 plus 0.0, you're going to get 4.0, because Java prefers doubles over ints. So that's why we get the 4.0 here. Similarly, if you want, we already talked about how to convert a string, you would convert a string to an integer, okay? And we said that the reverse process happens automatically, right? So integers are automatically converted to strings, right? So if you say system.out.println of 9, What if you do 9 plus 5 plus 1? Okay. What happens here is the 9 plus 5 is going to be treated. And then so it's going to be 1 with the 14 combined with the 1s. This is going to be 141. So it's able to evaluate the arithmetic expression, and then it does the concatenation. Okay. So you have to understand maybe in an order of operations, you would put the addition before the concatenation. So this just demonstrates how even if you see a plus sign here, these plus signs aren't really doing the same thing. And you have to understand how that works. And this should be able to work out. So you would have to, if you want to do a subtraction, you would have to put parentheses around it, because otherwise it's going to try to combine this string 1 with the number 2, and then that's a string, and subtract an integer from it. But so sometimes you have to be careful with these things, but in general it should be able to handle this, right? And so now this one string here would be concatenated with the integer 1, so now you would probably get 1411, and we can go ahead and try that, and indeed that's what we see here. You can also do Integer.toString, so you could say something like string x equals Integer.toString of 8042, and then you could see how many digits are in that number. So what if you say x.length now? So here x is going to become the string 8042, and it looks like that has 4 characters in it. It has 4 digits in it, and that's why we see 4 when we call x.length. So there's Integer.toString and Double.toString. So you could have said Double.toString. What if you said 6.261? And again, that's just going to create a string out of it. So now what if we want the index position of the second 6? So now you could say x.last index of, and then what about the 6 there? So if we take a look at, if we turn this into a string, then the first 6 has index position 0, the decimal point has index position 1, the 2 has index position 2, and the second 6 has index position 3. So we would expect this code to output 3, and that's exactly what we see here. If this last index method is unclear to you, you should go back to lesson 6 and review my discussion of string methods. So that's pretty much how it works. And then you can also parse doubles. So we talked about parsing a string back to an integer. What if you want to parse a string back to a double? So you could say something like double T equals Double.parseDouble of substring literal. What if it's a concatenated set of strings? What if it's 5 concatenated with a decimal point, concatenated with a 2, concatenated with a 1? Okay, so think about what that number is. That would be 5.21. And then what if you say W equals int of t? So what does that do? Well, int of t, the int form of 5.21 is just 5, but since we're saving this as a double, this should be 5.0. So now if you do u times 10, this should be 50.0. So let's make sure that we get 50.0 when we run that code, and that's exactly what we get here. We get 50.0 on the console. So hopefully this jogs or kind of helps you understand the conversion between ints and doubles and strings a little bit. So if we have to review here, we know that Java, so implicit casting means Java prefers doubles over ints, okay? It prefers integer division when only ints are involved. We saw that in lesson 2, I think. And then also implicit casting from ints doubles to strings when concatenation is involved between them. So if you combine a string with a double, that double is not going to be a string anymore. It's going to be the string representation of the double, and then you'll have 2 strings which will be combined. And then, remember Integer.parseInt of s, Double.parseDouble of s. So those will accept numeric strings and make an int or double out of them. Integer.toString of k accepts an int k and turns it into a string, or Double.toString, okay? And so you should just be familiar with that and try to practice around with doing these data type conversions, discovering what you get, and using the in combining those with the string methods. So be familiar with these things, and then in the next lesson, we'll talk about one more data type called the character data type, the char data type. From UMills03, thanks for watching, and please subscribe.